Welcome to this web lecture, Research Workshop 3, Choosing the Right Statistical Test. Before I want to talk about how you choose the right statistical test, it's first of all important for you guys to understand why it is important to choose the right statistical test. So for this, it's important to look at the MRP syllabus that we also have uploaded on Canvas. It tells you the content that the MRP needs to consist of, right? So we have the executive summary that you will need to provide at the very end, and then the report needs to be structured as follows. You will need an introduction that introduces your research problem and problem statement and explain why the problem statement is relevant for managers. Then you have a whole section on your research questions and subsequent hypotheses. And if you continue to scroll down, you see here on this slide that you're required to have a minimum of 4 research questions with hypotheses that cover all of the following statistical tests. So you need to include a chi-square test for independence, a 2-sample t-test, which also is called the independent sample t-test, a paired sample t-test, as well as the analysis of variance, which is abbreviated with ANOVA. So these are requirements of tests that you need to include, and therefore it's important to understand how you choose the right statistical test depending on your variables. So for that, let's open up the presentation and talk about the different tests. So in this web lecture, I will provide you with a short tutorial on choosing the right test. And you already saw some of these slides in the previous web lectures, but it's really important to understand how you choose the right statistical test, and therefore I quickly recap that here again. So the slide that you see here, this slide provides a template for choosing the right test. The slide really shows you that how you measure your variable dictates the type of statistical tests that you need to perform on the data. More specifically, also it dictates the tests that you can perform with the data. Or if you see it the other way around, keep in mind that you need to perform a set of statistical tests for your MRP, and that in turn implies that you need to measure your data in a certain way. But let's have a look at that in a bit more detail on this slide. So the first thing that you look at when choosing the type of test that you want to do is your dependent variable, which is indicated here on the left-hand side of this table. So you ask yourself the question, how is your dependent variable measured? And we differentiate between non-metric, so that is nominal or ordinal, or metric data, which would be interval or ratio data. If your dependent variable is measured in non-metric data, then you already know which test you choose. Then you would need to run a chi-square test of independence in any case. However, if you measure your dependent variable in metric data, for instance, you ask your participants to rate something on a scale from 1 to 5 or 1 to 7, or you ask participants how much money they would like to spend on a certain product, from 0 euros to 500 euros, then you have metric data. And then it's important to understand which test to choose. What you need to look at here is if your dependent variable is measured on metric data, then you need to look at your independent variable. The paired sample t-test is a bit of a special case, and we'll discuss it more later on in detail. But how do you decide between an independent sample t-test and an ANOVA? So in a second step, you then look at the independent variable, and you look at what numbers of independent groups or categories are available. If these are 2, for example, 2 groups like males and females, then you would be conducting an independent sample t-test. If, however, you have more than 2 groups, let's say 3 or 4 or 5 groups, let's say because you have different nationalities, you have Dutch, Belgian, German, French, for example, then you would look at an ANOVA test. So that is a critical second consideration that you need to take into account when your dependent variable is measured on a metric scale. Then you need to look at the independent variable and see how many groups do I have in my independent variable. So let's assume as a dependent variable, we ask participants whether they buy clothes online in a yes or no question. So we have nominal data, as we know, and our independent variable is the gender of the participants. So we have male or females. We already know that our dependent variable is measured on a non-metric scale, and therefore we would choose the chi-square test for independence. The chi-square test for independence will simply compare the proportion of male participants who say yes or no to that question and compare it to the proportion of female participants that say yes or no to that question. And would assume that there are no differences between the answers, and the chi-square test of independence will tell us whether there are no differences or whether the differences between males and females and their response to the question, do you buy clothes online, is significantly different. Now, if you measure your dependent variable with metric data, for instance, you have a dependent variable where you ask your participants, how likely are you to order online via express delivery, on a scale from 1, unlikely, to a scale from 7, very likely, then you measure your dependent variable in a metric format, right? In this case, we have interval data. Then you need to decide, okay, am I running an independent samples t-test or am I running an ANOVA? Now, if our independent variable has two categories, in this case, gender again, male versus females, then you would run an independent sample t-tests. What we see here, for example, that on average, all males responded with a 3.5. They're actually almost unlikely to order online via express delivery, and all females on average responded with a 6.5. So what we would assume is, well, 6.5 is way higher than 3.5. Therefore, females are more likely to order online via express delivery. The independent sample t-test then tells us whether the difference between males and females is actually significant. Now, let's say you have a different order of independent variables. So you still have the same logic as with the independent sample t-test. You measure your dependent variable in a metric form, but now you have three groups. So imagine your independent variable measures nationality. And as we know, there are more than two nationalities. That's we need to use the ANOVA test because we want to compare three different nationalities. The independent sample t-test cannot handle more than two groups. We'll learn more about that in the next research workshop as well, where we do the actual tests in SPSS. So on this example, what you see here, we again asked three different nationalities on how likely they are to order online via express delivery. And what we can see here is that on average, Belgians seem to be more likely compared to Dutch or Germans. And the ANOVA will actually tell us whether these differences are significant or whether they're just random variations within our sample. Last but not least, a paired sample t-test is a bit of a different test compared to the other ones, because here what you do is you actually do not have any independent groups. So you do not compare males versus females or French versus German versus Swedish people. So you don't split your sample based on different categories. But what you do is you present them with two different metric dependent variables. So here the example that we have on the slide is we ask them first at a certain point of time, how likely are you to order online CO2 neutral delivery? Again, on a scale from 1 to 7. And then we ran some sort of intervention. So we maybe showed them a video that's promoting how, CO2 neutral delivery could reduce global warming, for example. And then we asked them at a later point, after they've seen the intervention, we asked them the same question again. And what the paired sample t-test is doing, it's kind of comparing the pre-measure before the intervention versus a post-measure, so after the intervention. So, and the paired sample t-test tells you whether the differences between the pre and the post-measure are significant. You could also use a paired sample t-test to compare differences in two different metric variables if you don't have any independent groups. So in sum, it is really important to note that measurement and scaling has quite a lot of implications for the statistical tests that you will perform. And as previously mentioned, you need to perform certain statistical tests for your MRP. So take a careful look at this slide and then see whether with the survey questions that you will design in your MRP teams, whether you'll be able to conduct those 4 different tests. Because you need to have all these 4 different tests that you see here on the slide later on in your MRP. And because these depend on your survey questions, it is very important that you design the survey in the way that you already have the tests that you later on want to run in mind. Because once you've collected the data, you cannot change the data that you have available. So it's really important to study this slide to make sure you design proper service for your MRP.